Okay, so in this function, let's start with the graph of the function. So let's do here the axis. We have a function going increasing and then stops increasing and then goes increasing again, right? That's basically how this function works. This point here is what we have seen is pi over 4, where acceleration is 0. You have slope 0 here. And the area under the curve is going to give you the displacement, right? So the area under the curve is going to give you the displacement, and we're going to integrate from 0 to 1, right? So an expression for the distance will be d equal to integral from 0 to 1 of the velocity with respect to time, and then we plug in the expression here is 2t plus cosine 2t with respect to time. So basically this is what you have to integrate. It's not hard. We have t squared, and then the derivative, the derivative of sine is equal to cosine, so let's add sine and sine of 2x. We are integrating, so when you derive sine 2x, we don't get exactly cosine. We need a factor half here for this to be equal. Okay, so when you derive sine, we get cosine and then a factor 2, which cancel with this half. So this is the integral of the previous expression. So we're going to evaluate this from 0 to 1. So we get 1 squared plus sine of 2 times 1 times half, and then minus 0. 0 because t squared is 0 squared is 0 and sine of 0 is 0. So you get basically 1 plus half of sine of 2. So this is the expression you have for the area. So let's say the area under the curve here is d, right? That's basically how you do this.